Chapter 5, Number 20. On vacation, your 1,400 kilogram car pulls a 560 kilogram trailer away from a stoplight with an acceleration of 1.85 meters per second squared. A. What is the net force exerted on the trailer? B. What force does the trailer exert on the car? And C. What is the net force acting on the car? So as always, we begin off with some sort of little picture, and we'll say we have the car, object 1, and a trailer, object 2, and they're connected by some sort of tow bar. The car pulls away with an acceleration A, and that means, of course, the trailer also has that acceleration A. Part A, the total force or net force on the trailer is just the mass of the trailer times the acceleration, which is 560 kilograms times 1.85 meters per second squared, or 1,036 newtons. And I'm going to jump to part C because the total force on the car, the net force on the car, is the mass of the car times the acceleration, which is 1,400 kilograms times 1.85 meters per second squared, which is 2,590 newtons. And really, we should probably call this one 1040 newtons for sig figs. Now, in part B, they haven't actually told us what other forces might be acting on the trailer. That might be friction with the road or friction in the axles and so on. And since we have no information about it, we sort of have to assume that there aren't such forces because there's really nothing we can do to talk about that. So we can just say that the net force on the trailer is just the force of the tow bar. So I should do a free body diagram for Bach 2, and this just says there's a tow bar pulling forward, and that's what I want. But we already know from part A that the sum of the forces on the trailer is 1,040 newtons.